Hi friends, myself is Dr.M.MADHIARASAN, Assistant Professor, Department of Electrical and Electronic Engineering, Bharat Institute of Engineering and Technology, Hyderabad. So previously we discussed about the induction motor control scheme. The induction motor can be controlled with respect to the stator side as well as the rotor side. So if you are talking about the stator side control methodology, by varying the stator side voltage, by varying the frequency of the stator side, and we are making the V by F ratio as a constant, and by changing the number of poles, we will achieve the speed control of induction motor with respect to the stator side. Next method is rotor side control methodology. So in that rotor side control methodology, we will achieve the speed control of induction motor by adding the external resistance into the rotor circuit and injecting the EMF into the rotor circuit. So by adding the external resistance into the rotor circuit, we will achieve the speed control of induction motor. And by injecting the EMF into the rotor circuit, we will achieve the speed control of induction motor. So today we have to discuss about the rotor side control methodology of induction motor. So whenever we are talking about the rotor side control methodology, it is only applicable for the slip ring induction motor. So we can't use the rotor side control methodology for the squirrel cage induction motor. See, the rotor side control method can be classified into two types. So first one is adding the external resistance into the rotor circuit. Second method is injecting the EMF into the rotor circuit. In the adding the external resistance into the rotor circuit, method of control is static rotor resistance control. The injecting the EMF into the rotor circuit can be again, that is we can say the injecting EMF into the rotor circuit, the alternative name is slip power recovery or energy efficient method. Method or drive. See, what is the disadvantage of static rotor resistance control methodology? So, we are adding the external resistance into the rotor circuit to control the speed of the induction motor. But what is the problem with respect to the rotor resistance adding into the rotor side? The thing is, if you are adding the resistance into the rotor circuit, the problem is the losses will be high and the power will be wasted. So that is the problem with respect to the adding the external resistance into the rotor circuit. So because of that resistance, the losses will be increasing and power will be wasted on that resistance. So to overcome this limitations with respect to the rotor resistance control methodology, the next method is proposed, that is injecting the EMF into the rotor circuit. So the alternative name of injecting EMF into the rotor circuit is slip power recovery system or energy efficient drive. So why it is named as a slip power recovery or energy efficient drive? Because so the disadvantage of stator resistance control methodology is we are adding the resistance into the rotor circuit. So because of that external resistance, the power will be wasted. So that is losses also will be increased. That is the major disadvantage with respect to the rotor resistance control methodology. So to overcome this limitations, we are recover that flip power and used in a useful manner, that is we can use for that motor power provision, or as well as we can supply that power to the supply also. Okay, that's why this type of system is known as a slip power recover, because we are recover the slip power, that is wasted power. So normally the slip power will be wasted, so we are recover that slip power and used in a useful manner to provide power supply for the motor, or as well as we can provide the supply to the supply also. So these type of control is known as a slip power recovery or energy efficient drive. So because we are recovering the power, so power cannot be wasted, so losses will be minimized. So that's why this method is also named as a energy efficient drive. So in this what we are doing, so we are recover the wasted power. Normally the slip power will be wasted, so we are recover that slip power and utilized for the motor power provisions or supply to the, that is we feedback that slip power to the supply also. So again the slip power recovery system can be further classified into two types. So one is static Kramer method, Kramer method or drive. Second one is static Scherbius drive or method. See here what we are doing, so we are injecting the EMF into the rotor circuit, we can control the motion of the induction motor. So as we know this is the rotor side control methodology, so only applicable for the slip ring induction motor. So the rotor side control method is not applicable for the squirrel cage induction motor. So in that injecting EMF into the rotor circuit, we are having two cases. So one is my injecting EMF will aid the rotor EMF. So resistance value will be decreased. Second case is my injecting EMF will opposes the rotor EMF. So the resistance value will be increasing. So these is the two cases with respect to the EMF injecting into the rotor circuit. So one case is my injecting EMF will aid the rotor EMF. So that thing is we can reduce the resistance. So if the resistance value will be decreasing, as we know that is torque is directly proportional to the S, right? So if you rewrite this equation, my rotor resistance is inversely proportional to the torque. So if my rotor resistance value will be increases, my torque value will be decreases. If my rotor resistance value will be decreases, my torque value will be increases. So the thing is, so if my injecting EMF will aid the rotor EMF means my rotor resistance value will be decreasing. The another case is my injecting EMF will opposes the rotor EMF means my resistance will be, that is rotor resistance value will be increasing. So based on that injecting the EMF, we will achieve the speed control of induction motor, that is slip ring induction motor. So in this method is known as a slip power recovery system. So here what we are doing, we can recover the wasted power and use for the motor power provision or as well as feedback to the supply system. So the losses will be minimized and the slip power will be recovered. So the motor efficiency also will be improved. So this slip power recovery system can be classified into two types. So one is static Kramer drive, second one is static Scherbius drive. Again the static Scherbius drive will be classified into two types. So one is DC link Scherbius, second one is Cycloconverter Scherbius. See, what we are doing with respect to the static Kramer methodology or static Scherbius drive methodology is, so by adding the inject, that is, we are recovering the slip power from the rotor circuit. So the thing is, the difference between the Kramer methodology and Scherbius methodology is, the static Kramer methodology is only used for the below synchronous speed drive applications. So we can't use the static Kramer methodology for the variable, that is above the synchronous speed applications. So the difference between the static Kramer and Scherbius is, the static Kramer method is only applicable for the, that is, it is suitable for below the synchronous speed control only. So we can control the speed below the synchronous speed only. But in the static Scherbius drive, we can control the speed below as well as the above the synchronous speed. So in the both method, what we are doing, we are recovering the slip power and utilized for in a useful manner. That is, we can provide supply to the motor or we can feed that power to the supply. So the losses will be minimized, the efficiency will be improved. The ultimate aim of this slip power recovery is to improve the efficiency and reduces the losses, because in the static rotor resistance control methodology, because of the external resistance, so much of power will be wasted. So that is the major disadvantage with respect to the rotor resistance control method. So to overcome this limitation, we can recover the slip power with the help of static Kramer method or static Scherbius method. So the static Scherbius method are then classified into two types. One is DC link Scherbius, another one is cycloconverter Scherbius. The thing is, we are recover the slip power, that's why the losses will be minimized and efficiency of the motor will be improved. The difference between static Kramer and the static Scherbius is, the static Kramer method is suitable for below the synchronous speed control application, but the static Scherbius drive is suitable for below and as well as above the synchronous speed drive control application. So with this, today's section will be completed. So today what we have discussed, we have discussed about the rotor side control methodology. So rotor side we can control with the help of adding the external resistance into the rotor circuit as well as injecting the EMF into the rotor circuit. So if you are adding the resistance into the rotor circuit, the demerit is, that is disadvantage is, the power will be wasted. So in order to overcome that limitation, the next method is proposed, that is slip power recovery. So what we are doing, we are recover the slip power and used for a motor power provision or feedback to the supply system. So that's why the motor will be performed in a high efficient manner and the losses will be minimized. So this is about the rotor side control methodology of induction motor. Thank you.